Let's just hold up a few minutes for others.
Sir?
Yeah, let's just hold up a few minutes for others. Then we get started.
Okay, sir.
Hello, Hikma, can you hear me?
Yes, sir, I can hear you.
All right, let's just wait to 1 more minute. That is 6:10. At 6:10, we get started, okay?
Okay, sir.
Salim, welcome to the call. How are you doing? Mm,
Thank you very much, sir.
how are you doing now?
I'm fine, sir. How are you?
Yeah, good.
Okay.
All right,
Please
let's
allow.
get
Uh,
started.
okay, please allow me 15 minutes to pray. I will be back soon.
Oh, okay, okay, no problem.
Thank you. Mhm.
All right, Hakeem, it seems it's just you and I on the call today. Regardless, let's get started.
Okay, sir.
All right, well, have you, before I go on, have you touched on deep learning before in the past, personally or somewhere, anyway?
Yes, but it was just NLP. I think we did. It's not deep learning per se.
Okay, NLP, natural language,
Yes,
right?
it's processing. Yes.
Okay, so what did you do on NLP?
It was they did. I think there was then convert using is it vocab and F the TDF first vectorizer.
CDIBM, CDIBM.
Yes, yes.
Okay. So, have you taken on some projects on NLP?
No, not yet, sir.
Why? What are you waiting for now?
I've been struggling with my laptop, so I'm a little bit
Oh,
behind, and they've not been
okay.
assigning assignments. I don't know whether it's only me. They've not been assigning any tasks for us, so
Okay, since when? Since when?
I think for the last 2 weeks, after we're given a project on predictive modeling with agriculture, I've
Yeah.
not seen any assignment, so we are far behind actually.
Mm, mm, all right, no problem. We'll get the result.
Okay, so
Okay, so what our advice is, I guess now your laptop is in good condition, all right?
not exactly, but I've gotten to borrow. I just borrowed it this weekend. I'll be able to use the person's laptop for now before I get my own fixed.
Okay, okay. So if you can, if you want to make the most of it, just quickly jump on a project. Their project. I believe you know where to check for projects on data camp, like outside the the ones
Well,
that are assigned to you.
yes, sometimes I look through the courses or there are parts where they keep suggesting challenges. I see projects under them, but I've never tried them. I only follow the project that are under the ML scientist or the associate data science for now.
Okay, that's nice. But I advise that you do as much projects as you can find. If you see them, don't ignore. You
Okay, so
understand? Because the more you do, the more you learn, and the more you understand, you achieve mastery in each of the concepts in machine learning. So if
yes,
you can
so
find a project, please jump on it and see it through. See it through.
okay,
Make sure you have learned something. Make sure you apply something new you learned in the same subject matter, which is NLP in this case, as an instance. You understand? This is how you get better. You get better by doing, not just knowing theoretical aspects. Theory just keeps you aware of what happens behind the scenes, the process through which the result is achieved. You understand?
yes, sir.
Why doing gives you that practical, you understand, edge in whatever you know for
Understood,
theory.
sir.
So, yeah.
Thank you, sir.
All right. So let's quickly run over the planning.
Okay, sir.
Um, yeah. So actually take too much time here. All right, let's get going. So I believe you heard of this word before. What do you think? What do you think about when you hear deep learning? When you hear deep learning, what first comes to your mind?
I think the first thing that comes to mind is AI, as in
Yeah.
something more
Okay.
deeper than.
And what I didn't get that.
I think what comes to my mind is mostly AI, so something deeper than just deploying models using supervised or unsupervised learning. So I think one of it is computer vision and other
Mm.
deeper parts of machine learning.
Okay. Okay. You're right. You're right. But you mentioned more than deploying models. All models will be deployed now, isn't it?
Yes.
Yes. Even deep learning models will be deployed now, right? You agree?
Okay, so
Hello, can you hear me? Or do you think it's only the other model that are deployed? Hope you can hear
no,
me.
I think this one I can hear you, sir. You also
Okay.
deploy in deep learning. What I meant or what I'm trying to say is that the deployments
Okay.
like this is more deeper than just the normal deploying or the normal supervised and unsupervised we are used to. Is like more
Okay.
technical.
Mm, mm, mm. All right. That's great. Someone just joined the call. Hi, Victor. You're late. Hello, Victor. Can you hear me? Hmm? It's not available. It's available, but not available. All right. Let's continue. Okay.
Okay, sir.
Now, deep learning is a part of machine learning. Okay.
Mm,
And machine learning is also a part of AI. So the
yes.
hierarchy is AI, machine learning, then deep learning.
Okay.
You see the connection?
Yes.
All right. So deep learning just have it has its how do I put it? This unique touch or approach when it comes to teaching machines to learn. You get it? Because all at the end of the day, what we do is we are teaching machines to learn, supervised learning, unsupervised learning, now deep learning. We all teach machines to learn, but the approach through which they teach machines to learn distinct them. You understand?
Okay. Yes, sir.
Yeah. So for deep learning, each unique touch is there's a popular word that flies around in deep learning or used, which is neural networks. Have you heard about that?
Yes, I've heard of neural network.
All right, that's fine. But before we get to that, just know that deep learning was or is inspired by how the human brain works.
Okay.
You get- What did I say?
It's inspired by how the human brain works.
Yes, and you'll see how that inspiration is implemented in its approach or algorithm. Now, the reason why um the reason why it says that it's inspired by how the human brain works is using this concept of neurons. And if you were once an attentive biology student, you remember that there were this set of cells, specialized cells for the nervous system that they call neurons. Okay, nerve
Yeah.
cells in the body is called neurons, if you remember.
Yes, sir.
And nerve cells they are prominent in two areas, spinal cord region and the brain. Now, in the brain, there are a lot of functions to which the brain handles, and one of them is learning. So this is the particular the neurons there, the neurons in the center for learning in the human brain, which is where the inspiration for deep learning um sprung out from.
Oh,
Now, in this case, we are using artificial neurons to learn, to help the machine learn. You get?
yes, sir.
Yes. So an example is you show the computer thousands of pictures. Let's say pictures of meat pie. I guess meat pie is your favorite snack.
Yeah.
Okay. So you showed the machine thousand pictures of meat pie and pictures that are not meat pie. You get pictures in
Yes.
this sense. So the computer now learns, okay, meat pie is called this way. It has some tricky ending. It has this shape. The colors are mostly, I don't know if that's orange or how should I call it, brown. Around that, it lets the color. So with that now, later when it sees the new image, it can tell, oh yeah, this is the meat pie. Oh no, this is not a meat pie. You get.
Mm. Yes, sir.
So now, what is this neural network? What's this neural network? Let me just get a brief of deep learning before I scroll through the slides. Now, this neural network we are talking about now is layers of neurons. Remember, we talked about neurons. You know what neurons are now?
Yeah.
Artificial, yeah, learning concepts in deep learning. Yeah. So now it's a layers of these neurons. That means it's a connection now of various neurons to aid how the machine learns. You understand?
Yes.
So this layer of neurons process data step by step. Remember, we mentioned layers, step by step.
Yeah.
You get,
Yes.
yeah. So now let's go through the slides. Deep learning is everywhere, and that's true.
Mm.
You would you be in shock if I tell you that ChatGPT is a product of deep learning?
No, think
Okay,
because
you knew about that.
yes, because as I said, whenever I hear about deep learning, the first thing that comes is AI. Anything involving AI.
It's not anything AI because there are other aspects to AI than machine learning where deep learning
Mm.
falls under. You understand? So just get
Yeah.
your facts right, okay?
All right.
It's safer to say it's one integral part of AI, not
Okay.
everything entirely AI, okay?
Okay, so thank you.
Yes. So the likes of ChatGPT is the product of um deep learning.
Deep learning.
And yeah, the likes of Google Translate, you know, Translate, right? Speech to
Yes.
text. Yes.
Yes.
Face recognition software. Those face recognition softwares, they are products of deep learning.
Learning.
Speech to
Mm.
text, text to speech, they are all a wonder from deep learning. So when we say deep learning is everywhere, believe it, it's everywhere actually, because this is just a snippet of the examples I've mentioned.
Mm.
In fact, deep learning is one of the power engines for self-driving cars. So it's a very wonderful concept. So what is deep learning? Okay, you see here, this diagram says already tells us that deep learning is under machine learning. You can see, right? And we mentioned layers just a few minutes ago. Now, these are the layers. This is the summary of the layers defined in deep learning. Input layer. You can see my cursor, right?
Yes.
Okay, input layer, hidden layers, and output layer.
Yes.
Now, if you see the difference between this slide and the second one, what do you observe? This first slide and the second
Um,
slide.
I think in the first slide, the hidden layers are not much. It's just like one. Um, the neural network is not dense. For the second slide, there are more dense neural networks. The networks are connecting, so the hidden layers are very much between the input and the output.
Yeah, that's true. That's true. You got that correct. Yes. The difference is the amount of hidden layers in both slides. That makes difference. And this is this is this is vital towards how complex you want the machine to learn. Like, yes, you want the machine to learn using deep learning. The more hidden layers, the more complicated or complex the learning pattern is. You understand? And this
Yes.
is one of the concepts that makes it deep. You get having
Yes, sir.
so many layers, hidden layers in specific, through which the computer can learn as much patterns as there is in the given problem for the given problem. You understand? That makes it deep. You get the idea?
Yes, sir.
As you mentioned earlier, deep learning networks inspired by how the human brain learns. Deep learning network, yeah, inspired neurons. Okay, neurons give birth to neural networks. Remember we talked about it. That neurons, the layer of neurons gives you neural networks, right?
Yes.
All right. So for deep learning, the models require large amount of data. Actually, yes, it's not ideal to use a small amount of
Data set.
data for deep learning tasks. Do you know why?
I think it's mainly to overfitting.
Yes. Anything else?
It won't allow the machine to learn because given that it's deep and there are different patterns that needs to learn, it won't be able to grasp. Okay, if it's giving something out of the box, it's not going to be as if and give as be as effective as it should be.
Well, I think you sound contradicting. It will be effective in the training phase because it will actually learn very well. It will learn because just imagine it has a complex structure of hidden layers enough enough to learn patterns in a data. But if the data is overfit, I think that's just the major idea we should dwell on. You understand?
Mm.
Overfitting overfitting is the common reason why you don't pass small amount of data or use small amount of data for deep learning purpose. Do you understand now?
Yes, sir.
Yeah, you got the idea. Overfitting is almost inevitable. Yeah, because the complex structure of deep learning is not wired for small amount of data. You get
Yes.
yes. In fact, most of the time, uh, for deep learning use, you might find yourself chasing how to fix overfitting issues. You understand?
Yes.
Yeah. So let's go on. So you can see this school of thought suggests that at least 100,000 data points.
Yes.
Yeah, at least 100,000 data points. I mean, that's a lot. At least, and that at least.
Yes.
So PyTorch. Now, remember the this course is deep learning with PyTorch. So PyTorch is a deep learning framework actually. There are so many frameworks you can use to implement deep learning. There are the likes of Keras. Yes, there's Keras, there's one other like that. I think TensorFlow. But PyTorch is one active, yes, it's an active community of framework. You understand what I mean by active community?
Um, Not exactly.
Okay, let me explain that. Okay. So active community means there are a lot of tools. There are a lot of tools right now, like libraries in almost all languages. You understand? As you are now, I think you can decide to create a library or a framework tomorrow. You understand? Maybe something along the sides of implementing deep learning. And for one or two reasons, you're not able to maintain your framework for some time. You
Okay.
understand? That impairs the use of it because it's a fast moving field tech. So there are certain things adjustment you might have to do for frameworks as we go along. You understand? But if you're
Yeah.
not readily available to understand, fix these changes, fix bugs as they arise, that makes your community inactive. You understand?
Yes.
Yes, you might also be a group of people who come together to create this framework. But what matters is your community active or not? So that okay, if I find myself using a framework by Hikma and Co, and 2 months down the line, there's an issue with using your framework, or there's an adjustment, or there's a new feature I would love to request from you, and I can't find that activeness to fix it. I will have to leave your framework, isn't it?
Yes.
Yes. So that's what I mean by the community and the activeness and inactiveness. So
Mm.
PyTorch is the popular and common deep learning framework that has a very active community. It was originally developed by Meta AI, and now it's part of
Okay.
the Linux Foundation. It's user friendly, yes, actually, and it has similarities with NumPy. You see why they mentioned that. Now, Tensor, there's something called Tensor. Tensor is, can you hear me?
Yes, I can hear you, sir. But your
Great. My words.
there are like background noises when you start speaking. I don't know, but I can hear you.
Is it better now? Is it better now?
Yes, it's better now.
All right. Salim, are you back for me now? Oh,
Yes, sir, I'm back.
okay.
Hmm.
All right. It's okay. Since if your background is not noisy, you can just keep your mic open. We are not much on the call so that it can be interactive, fast, and we get things done and close on time. Okay. Salim, just unmute your mic.
Okay, sir.
All right. Yeah, the background is not noisy. That's it. You joined in late. Okay. Have you gone through deep learning before? Have you at least you have an idea? You've seen something on that?
Yes, I have a background, but theoretical aspect, not practical aspect.
Okay,
I have done,
theoretical, then that's great.
yes, I
Okay.
have
What do you know
done
about deep learning? Just
deep
share.
learning. Pardon?
Yes. What do you know about deep learning? Just share with us.
Deep learning is an extension of machine learning. So it
Okay.
is much more complex than machine learning, and it
Mm.
uses neural networks to learn patterns from data, and it requires huge amount of data. So it is a subset of machine learning.
Yes, it is a subset of machine learning, but you also mentioned something that it's more complex than machine learning. That sounds contradicting.
Which one is that, sir?
I think you mentioned that deep learning is more complex than machine learning. That sounds
Uh,
contradicting. Do you agree?
Yes, I agree, but I mean in the sense that it goes deeper than machine learning. It goes deep in one section, not generally learning. How do I put it? It is specific, like it's a subset of machine learning, but it go deep down into the subset of machine learning. Maybe
Okay.
you get what I'm trying to say.
Yes, I get it. I get it. Maybe I don't know. Maybe the word you're trying to use is complex. It's more complex than other type of learning in machine learning, such as supervised and unsupervised. Is that it?
Okay, okay, yes, sir.
Is that what you meant to say? I'm not trying to speak for you. Sorry, I just wanted to be sure I get.
Yes, yes, that is what I was trying to say.
Okay. All right, no problem. Then I see you have an idea. That's great. Well done, Salim.
Thank you, sir.
All right. So let me just, for your sake, let me just quickly run over what we mentioned earlier. Another thing you need to know about deep learning is that it's inspired by the human brain. Did you
Yes.
know that before?
Yes, sir. Because our brain is a network of neurons, that cells connecting different parts of brain
Yeah,
that make allows us to think or process
yes,
information.
yes, exactly, exactly. You got that correct. Well done. So
Yeah.
yes, yes, yes. So that's where the concept of deep learning was scratched out from. So
Okay.
another thing to note is the model, deep learning models require large amount of data because of the innate complex nature of deep learning models. You get so
Hmm.
it requires a lot of data. So earlier
Hmm.
on, I and Hakeem touched on why you shouldn't pass small amount of data to deep learning models, and it's because of overfitting. Overfitting is the major reason. When you
Hmm.
have an algorithm, or
Hmm.
yes, when you have a model and an algorithm that has a complex pattern of learning, it,
Hmm.
it leads to overfitting. That's
Hmm.
something that's inevitable, you understand? So you have to match that structure or that concept. So if the model has a very complex way of learning, then you need to pass it a lot of data to avoid overfitting. You understand?
Hmm. Yes, sir.
So this school of thought suggests at least 100,000 data points is fair enough to get started. So the
Hmm.
next thing we touch on is the use of PyTorch. So along this course, they use PyTorch to implement deep learning. You understand?
Yes.
And that's where you join the meeting. You join the meeting. So
Okay.
now another thing you need to know in use of PyTorch is that there's something called tensors. Tensors are the base form through which deep learning models want us to pass the data. You understand? Like
Hmm.
you can't just have if you look at this import touch, my list equals to a list of data points. Now it's you can't pass this as it is. You understand?
Hmm.
So PyTorch wants this in a tensor form. You understand?
Okay. Yes, sir.
So you convert to tensor using touch to tensor and you pass the data points you have with you as the input data. Do you understand?
Hmm. Yes, sir.
Yes. And tensor is actually similar to array or matrix.
Hmm.
You know array now, right? Array is just another way of saying the list as
Hmm.
well as matrix.
Yes, sir.
You get yes. All right. So once you have um once you have this tensor structure, you can see the shape of the data points you have with you. You can see here touch
Hmm.
dot size. When you print the tensor dot shape, you get the shape of your data. You get
Okay.
you see it right? Two rows, three columns. You see that
Hmm.
now?
Yes, sir.
Yeah.
Yes. Akim, are you with me?
Yes, I'm with you, sir.
All right. So you can also see the data type of the data points you have with you. They are all integers, which is here. You can see it here now. Tensor dot data type dot int 64, right?
Hmm.
Yes.
Yes. So tensor operations. There are operations you can do with tensor objects. Let me call them objects. Now, for tensor objects, if you have two tensor objects, you can perform operations such as addition, subtraction, multiplication, and the likes. You get, but
Hmm.
there is an important thing to note. These these tensor objects you want to perform or pass through some operations, they have to be compatible, and compatible means you need to have similar shape. You know that tensor dot shape, right? You remember
Hmm.
tensor
Yes.
dot shape now?
Yes, sir.
So what that means is if you have a tensor object of 2, 3 and another of 3, 2, do you think they are compatible?
No, they are
No,
not.
no.
That will throw in error if you try to perform certain operations with them. You
Hmm.
get?
Yes, sir.
Yes.
Yes. So you can see here an example, quick example, compatible shapes. The tensor touch the tensor 1 1. These have the shape of what? What's the shape here for these two? What are the shapes?
Two, two, two,
What?
two,
Two two.
two.
Salim, do you agree?
Uh, actually, no.
No,
I
why?
can
Why
see
please?
one, another one, two. So,
Okay. All right. So it's actually two two. Let's see the proper let's read it properly now. See,
okay.
view this, just imagine this as a table. Are you with me? And
Yes,
Salim.
yes, sir.
All right. So this as a table now. Moving horizontally are rows, right? When you move from
Mm,
left to right, those are your
mm,
rows, right? So let's
mm,
count the rows we have. Row one, right? That is this
yes.
one section.
Mm,
Row one. Then we have the other one, which is what two two row two, right?
mm,
Yes.
Then still visualize as a table. When you move vertically,
yes.
that is up down.
Column
What do
one,
you get? Column
column
one,
one.
thank
Column,
you, and column two. So what
Mm,
shape do we have?
two rows, two columns.
Which is two
yes,
two.
yes, two.
Salim, you agree now, right?
Yes, yes, sir.
Then this one here, this particular one, which is E, has Hakim. No, Salim, I'm asking you, how
Okay,
many?
sir.
What's the shape of this now?
Two. That is two, three.
Oh, right, that's great. Thank you. So
Yes,
you
sir.
can see two three and this, which is two two, are not compatible.
Yes,
And if you
sir.
try to run operations such as addition, subtraction, you get
Mm,
an error because you can see
okay.
here that the size or shape of tensor A must match the size of tensor B. You get the
Okay.
idea now, right?
Ye- yes, sir.
All right. So multiplication is another operation you can um, perform on tensor objects, which you can see here.
Mm.
Um, yeah, another multiplication. There's a pattern of multiplication called matrix multiplication. I don't know if you guys have heard about it before. It involves adding and multiplying at the same time.
Yes, I did it in during my undergraduate studies, but it was long time ago. But I can go over
Long.
it and revise it.
Okay, yes. Yes. You can if you have the time later. It's an interesting. Okay, I think that, oh, they explained it here with the example
Eh,
given. Great. So
eh,
this matrix, okay, you can see here as I mentioned, it involves look this part I'm highlighting now. Have you seen the highlighted part?
yes, sir.
All right. So you can see multiplication and addition at the same time is used. What are they
Mm.
multiplying?
One
One
times two
times two plus
yes,
one times three.
times three. Yes,
You see,
yes,
one the first data point on the first row
yes.
times first data point on the first row, then second data point on the first row for A
Mm.
times uh, first data
Second
point on
data.
the second row for point B. You
Yes.
see? All right. I don't want to dwell on that because sometimes there are no need to do all those operations anyway,
Mm.
because PyTorch have the way of abstracting all those. Deborah, welcome to the call. Hi, Deborah. Same thing here. All right, let's continue. Neural network layers.
Mm.
Now, as I mentioned earlier, their neural network is made up of layers:
Mm.
input layer, hidden layers, output layers. Those are the three basic layers you find in the neural network on deep learning.
Mm.
So the input layer is where you pass in the features. You remember supervised learning and all those things. The word feature shouldn't be a new concept. You
Mm.
get features is actually the input data you pass on. through which the model will learn from. You understand?
Yes.
Yes. All right, that's it. So you pass in the features, it goes through the hidden layers next, and gives an output, which is the final solution to the problem that the case is named. All right. Yeah. So predictions, you can see output prediction. Yes. So, all right. Fully connected, everyone to linear model. Let's see if they actually explain the game. All right. So this part is designing a neural network. So first you import torch.nn as nn. For convenience, you just import as nn. Do you understand?
Yes, sir.
Yes, sir.
All right. So you create input tensor with the three features. Okay. Now you in this case they assume that you have three features to work with. So you first convert. Remember the first thing you convert to what's a tensor object, which is convenient for the deep learning use. So input tensor is equal to tensor. You pass in the available features, and that gives you the input neuron for the input layer. You get
Mm.
then maybe in this case you're trying to predict classes which will become the output neurons, all right linearly. So in this case now, this is a very basic form of deep learning. Like in this case, just the simple linear layer that is being created. Now this linear layer is created using linear method. Then you pass in the number of features you want to work with and the output features you desire to have. These output features, basically, you can say, okay, 3, 4. It depends on the desired output you want, right?
Yes, sir.
So expanding the equation or expanding the implementation, you see something else has been added, which is this line. Every other thing that's the same for the other slides. So in this case now, we are passing the input tensor we created here. That tensor object we created using our data points, features data points. And this initialized layer takes in that input tensor you can see here. You can see, right?
Yes.
To give you an output. Yeah, so this is basic. This is a basic linear layer implementation in deep learning. Now, after that, I may pass. Remember, we mentioned we already initialized that we want two output features
Okay.
or output neurons. Do you remember?
Yes.
Or you can see here already. So that's why we are getting two two results. Can you see them here? So this output is basically the prediction the model have been able to come up with this linear layer. You understand? Yes. So another important thing to know is, in fact, I'm going to ask you guys, Hakim, what do you remember about it?
Sir?
What do you remember about weights in
Wait.
machine learning? What do you remember about weight? Yeah, what's our
Let me see. I can't remember anything about it.
You can't remember. Salim, can you?
Star waves are like features that can make the algorithm learns.
Is if they are like pictures. Do I agree to that? There's more to it anyway. There's more to it. Not just weight. It's like quantifying the importance of the features
Yes.
you have, yes, in your data points.
Because
Do you understand? Do you understand?
some are better than others for prediction.
You see, sorry, Salim, go over that again.
And because some features are more important than others for making the prediction, so that is why we are using weight, because some features carry
Yes.
more weight than the others.
Mhm. That's very much true.
Mm.
Hikma, do you understand?
Yes, I understand now.
Yes. It's like giving value. When even in supervised learning, in unsupervised learning, all algorithms have the way of assigning weights to features. That's the word. And they assign weights to features based on their importance, like how contributive they are to the end goal. You understand? So if you have a
Mm.
situation like uh, let me see. Okay, making of the meat pie. If you have the making of meat pie, you have ingredients including flour and let's say it's sweetener. I don't know if they use sweetener in meat pie, but in this case now, which of these feature or ingredients is most important to make a meat pie?
I think floor.
Yes, it's flour. So in this case, you give more importance to what flour, isn't it?
Mm.
Yes.
So these are just typical situations that happens in models and their algorithms. Different models have different ways of assigning importance or weight features. You understand? You understand? Like how much do you weigh enough to contribute to the end result?
Mm.
Is it
Yes, it's very clear, sir.
all right? So there's another called biases. Please, I believe because these weights and biases are very, in fact, they are basic. They are basic for machine learning. So these are things you guys should be aware of this, like well equipped with. Who can tell me what bias talks about? What it means?
Unintentional error or something that can make the result to deviate.
Hmm. Okay, like that. Hikma, anything from you?
Bias is could be the outliers that can, like you said, that can change the results or that make major changes that makes the results more gives more importance to another future more than it.
You see, it's what again? Sorry, I didn't get that.
I see bias is like outliers that end up making future and end up allowing futures have more importance than they should.
Okay, okay, but you have a point, but that's one positive uh, instance of bias. It is not bias. Outlier
Uh,
is not bias. It could lead to bias. Do you understand?
yes, I understand.
Yes. And like Salim also mentioned, which is true. Another addition to bias is first bias is an error actually. Bias is an error. It's an error that results from a lot of things. It could be incorrect assumptions in the model from incorrect data, for instance, or insufficient data, or data that is not representative enough. You understand?
Mm.
This leads to inaccurate prediction. You understand?
Yes.
That's why you see yourself trying to cut down on. You remember loss. Do you remember loss? Loss functions.
Yes.
Who remember loss functions? Like who can tell me about loss functions?
Actually, I forgot loss functions.
Please, please, please. These are basic concepts in machine learning. The things now that we are talking about. So
Mm.
loss functions are ways we calculate bias or inaccuracy. It's a way we quantify the total error we have. Um, and each learning type, supervised learning, unsupervised learning, deep learning, they have their ways of calculating loss, which is generalized. Loss function is like a generalized term for each type of learning in machine learning. Are we together?
Yes,
Yes.
sir.
Yeah, so in supervised learning, we have loss functions in supervised learning. And the specific types of loss functions there, I think one is mean squared error. Do we remember now?
Yes.
Yeah, that mean squared error now, you remember you used to quantify um, the accuracy or error that
Yes.
your um, linear
Model.
regression model. Yes. Salim, you remember now?
Yes, sir.
Thank you. So unsupervised learning has its own too. Okay, in supervised learning, I think there's one again. For logistic regression, what there's one loss function we use. I can't remember. Can't remember. Who can remind me? Logistic regression.
We use the F1 score.
Thank you.
Or
Yes. So there are a lot of them actually. These are loss functions. Is it clear now?
yes,
Yes,
sir.
sir.
Thank you. So loss functions, I wanted to mention that loss functions is how we quantify the bias in our model. So this bias is actually an error. It's an inaccuracy between what was predicted and what the ground truth is. In this case, ground truth means the correct uh, answer. You understand? During training.
Mm.
Is it clear
Yes, sir.
now?
Yes, sir.
Yes.
Yes. Thank you. So, and there's please, I would encourage us to go and read up on. Please go and read up on weights and bias so that you understand it very much. These are very vital. Please, high
Okay, sir.
bias now is a situation of high bias. High bias leads to what's under fitting. Why? Because the
Mm.
model is too simple.
Yes, sir.
Anyway, let me leave that as an assignment. I shouldn't be talking about this now in detail. Please, I encourage us to go and learn more about it. So, because
Okay,
they
sir.
Okay.
are very vital, they are very, very vital because in the hidden layers, once you pass in the input feature, yes, the pattern is big picture. In the hidden layers, there is these assignments, there are series of assignments of weights and calculation of biases that goes on
Mm.
until you get to the goal, to the end goal. You understand?
Yes, sir.
Now, to see the weights, yeah, to see the weights that have been assigned, you can use linear. Remember, we created a model, linearize a very simple linear layer, deep learning
Mm.
layer called linear layer. Yes, which is
Yeah.
linear layer. Just yeah. Linear layer dot weights helps us see the weights that have been assigned. You can see, you can see this brief explanation of what weight is here. Reflects what the importance of different features. This should be clear by now, right?
Mm.
Yes.
All right. So then bias, you can see the bias in the layer through dot bias, which provides the neuron with a baseline output. All right, let's go on. Now, for instance, imagine you have input features. One of the features was temperature, humidity, and wind. For output, let me see. Okay, so in this case, we are trying these features are used to predict if it will rain or it will be cloudy. You get?
Mm.
And you can see now, yeah, at the end of the day, humidity feature we have the more significant weight. Why? Because among these three features, humidity is one of those key items one can use to predict if it will rain or it will be cloudy, actually.
Mm.
Do you know what humidity is?
Yes.
Do you
Mm.
guys know what humidity
Yes, sir.
Yeah.
Yes, and you agree among these three features, it's the more vital feature.
Yes.
Yes, sir.
Great. All right. So hidden layers and parameters. Okay, let's talk about hidden layers and parameters. Now you have the power with the use of the framework. You have the power to have as much layers as you want to. Now, how do you do that? Through a method available in PyTorch known as nm.sequential. You understand? So what you do
Mm.
is you in nm.sequential, you pass in you indicate as much layers as you want. You can see these have 3 layers,
Mm.
3 linear layer. And the first layer, you pass in what? The number of features you want.
Mm.
You get? And the last layer, let me focus on the layers in between. The first layer is what you pass in first is the number of features, and what you pass in last is what the number of classes that you
Okay.
want, which is the output. You understand?
Mm.
Yeah.
So now let's talk about these other numbers and this other layer that is in between. But let me see if anyone has something to say about it before I talk about it. Anyone?
Sir, please can you come again?
Okay. I talked about, or just 3 seconds, I talked about the first layer and particularly the first value that goes in, which is the number of features you have, the input data, right? And I
Yes,
talked
sir.
about the last layer, which the last value here is the number of classes you wish or desire to predict, however the use case may be. Do you understand?
Sir.
So now the question is, these states, these values that are in between those first and second layer, who have something to say about it? Like, what do you think they are? What are they doing?
Maybe you have supplied various features and weights, and the machine will quantify those features and select the best ones that can assist in making the accurate predictions. That is why they decreased from 8 to 4.
Mm, mm,
I
Yes, sir.
think it's the neural network because in the slides you've shown before, there's this connection whereby if you have three inputs,
mm.
for the first linear layer, and you can see the output
Okay.
you want is only two. So for this test, it has a number of futures,
Mm,
and then I think the number is eight. Then in between, it has this eight that is coming in the input that is
mm.
connecting to four. Then the four now at the end of the day is what you want as your output.
The four is
That's
what
what.
we want as the output.
Yes.
Okay. You guys tried. I love how you engage your mind to reason it out. But this is the better explanation, okay?
Okay.
All right. So the first, like I mentioned, the first value is the number of features you want to pass in, right?
Yes.
The number of classes, and this is for you, Hikma. The number of classes could be quite different from this one.
Okay.
Yes. Now, these end features there, just imagine that this is something they initialize somewhere. Let's say, okay, before this model, Salim, are you with me?
Yes, sir.
Yeah, before the creation of this model now, there's somewhere they initialize number of features is equals to the tensor form of the input data, right?
Yes.
Yes.
Then second line of the code following the initialize n underset abyss, how do they call this? This dash classes is equals to that in Python code to Python form is equal to 2.
Mm.
Are you
Yes,
with
sir.
me?
Yes, sir.
Yes.
Mhm. Yes. So that means n classes could be different from 4. You understand now, Hikma?
Yes, I understand.
Then
Yeah.
this 8, 4, and 4. Now, for the first line, number of features, then 8. What 8 means here is we are telling this linear layer that, hey, when you take in the input data, which is the number of features, I want you to output eight, but eight what? Eight outputs.
Hmm.
You
Okay.
understand?
Yes, sir.
Yeah.
Eight outputs. You understand now? Then I'm telling the
Hmm.
second layer that, hey, when you take in eight outputs, which is coming from here, you can see the sequence. You can see the
Hmm.
uniformity. This one
Yes,
starts
sir.
with
Yeah.
the eight that is taking in, right?
Hmm.
I want you to output what? Four
Oh,
outputs. You
Yeah,
get now?
okay. Yes, sir.
Then the last layer, same thing. These four outputs that the second layer have output, take it in and output what? The number of classes
no.
I designed could be two, which could be one, it could be three. You understand?
Hmm.
Yes. Sir.
Is it clear now?
Yes, sir.
Yes. Sir.
All right. So that's it. Input is passed through the linear layers. You can see input is passed through the linear layers. So at every point of this layer, that input and they are outputting something as well. You
Hmm.
understand? Until the
Yes.
final prediction. You
Hmm.
get
Yes.
any questions?
Sir, before we move on,
Okay.
are we the ones to determine the number of layers, or it is left for the machine to predict and come up with the number of layers?
No, no, it's left to you. It's left to you to indicate the number of layers you wish.
Okay.
Yes.
Hmm.
And also there's a way you can anyway, when you go further with using deep learning, there's a lot to learn in it on
Yeah.
how the implementation goes about. There's a way to go about this. Like imagine, okay, you wish to have a lot of layers. There's instead of doing it one by one, there are certain ways you can do this. Maybe writing a for loop. You understand?
Hmm.
Yes, and different concepts. I think that there's a library like that that helps you just get how many layers do you want, and it gets to you understand, work it out behind the scenes without having to do this one by one. But for the sake of this class, just
Hmm.
see how everything goes structure by structure. You understand, so that you have a deep understanding of what is going on behind the scenes. You get
Okay, sir.
all right. So yeah, as you mentioned earlier, we start layers using nn.sequential and okay, yes, yes. Input is passed through the linear layers in expression are the hidden layers grid, and features and end classes are defined by data sets, which is true. Yes, which is true. Because look, just imagine you have a data set now, and the data set contains what? Number of contains features,
Hmm.
you understand? And the number of features it has is what? Four. If the number of features is four, you can't just come up start with five. That's not uniform, isn't it?
Hmm.
Yes.
Great. Then if the number of classes at the end of the day for this data set is two, it's not I come here and say one, right?
Hmm.
Yeah.
That's why it mentioned here that the number of features and the number of classes you should pass in here should be defined by the data set you have.
Okay.
Do you understand?
So
Yes. Because the data set is what? Is labeled. Do you agree?
yes.
Great. Salim, do you agree?
Yes, sir.
Yes. So for the labeled data set now, if the end output or the predictions is three, you shouldn't use two. It's two, you shouldn't use three. You understand?
Hmm.
Mhm. So adding layers, yeah, yeah. So you can see now that nn dot sequential is what is helping us add as much layer as we want. Are you seeing it?
Yes, sir.
Yes. You can see this layer, next layer, another layer, then this layer, then another layer.
Hmm.
All right.
But
So
the number of hidden layers are alternating.
yes, yes,
Why is that,
it
sir?
is. Remember when we talked about from this diagram,
Hmm.
I believe this is from this thing we talked about. You see these numbers?
Yes, sir.
Yes. So each layer have a certain number of outputs and if it's they're taking it. You understand?
Yes,
So
sir.
just imagine this layer was getting four out. It got four output from this one, which is now its inputs. You understand? Which is now its inputs now, right?
Yes, sir.
For this layer one. Okay, for this hidden layer one. Do you understand
Mm.
now?
Yes.
Then hidden layer one outputs what? Three data points. You understand?
Yes. Yes,
Yes,
sir.
sir.
So the next one. Are you seeing where how randomized the numbers are?
Mm.
Yes.
You
Okay.
understand
Yes.
now?
Yes. Yes, sir.
All right, thank you.
Mm.
Adding layers, okay, we've seen this. Now this is the neural network or network with three linear layers, okay, as you can see here. Yeah, you can see that here. Okay, input 10. Okay. See what we were explaining earlier now. Takes 10 features. You see, starting the starting layer is always where you pass in your input feature, remember. So now this taking 10 features and has put
Mm.
what? 18. You can see
18.
here.
Yes,
So
sir.
what's going on here? Tell me, Salim.
Take 18 and output 20. 20,
Salim, what's going on
26.
here?
Yes.
It
You are
took
telling.
Salim, are you there?
Yes, sir. So the second layer says,
Mm.
let it take 18 inputs, 18
Um,
pictures, and output
okay, Hikma. Hikma
28.
complete it. Hikma complete it. What's going on the last one?
on the last one, it takes in the data that is coming in and outputs 5.
And I've put five. Thank you. So everything is now clear, right?
Yes, sir.
Yes.
All right, that's great. Hmm. Still the same explanation going on. Takes 20 outputs five. That's great.
Mm.
So now layers are made up of neurons. Here we've established this fact. Fully connected. Yes, this word, you see, this word it was highlighted. Now, the reason why it's highlighted because the connection is that there's this consistency between what has been outputted from the previous layer and the number which it is taken in from the previous layer.
Mm.
Can you see? The
Yes, sir.
connection is there. 18,
Mm.
18, 20, 20. Are you seeing it? So that's
Yes,
why it's
sir.
Yes.
mentioned fully connected. And it is fully connected when each neuron links all neurons in the previous layer. You understand?
Mm.
All right. Okay. Okay. Oh, yes. You can see all those things are built actually the neurons in the layer. You understand?
Yes, sir.
That means in this case, 18 output forms 18 neurons in this layer. You understand? To output 20, which forms 20 neurons in this last layer to output five neurons as our final data or result. Did you understand? Understood, rather.
Yes, sir.
All right. Layers are made of neurons, fully connected when each neuron links one neurons in the previous layer. A neuron in a linear layer performs a linear operation in on the previous layer, that's true, has n plus one parameters, n from inputs and one for the bias. Yes. So you can see how bias, the concept of bias is creeping in into this. It's very important because during these operations, each neurons is aware of the bias. They use bias as well during these their operations. That's why you're seeing that okay, inputs of bias leads us to an end goal. You understand? So you can see how vital bias is, right?
Mm.
Mm.
All right. More hidden layers equals to more parameters, equals to higher model capacity. Yes, yes, yes. So the more hidden layers you have, the more complex your model is. That's what this is trying to talk about. This slide touched on. The first layer has 1 million, this million has 8 plus 1 parameters, 9 times 4 equals to 6 parameters. Hmm. Model capacity. Now, there's something there certain operations going on under the hood during deep learning to create parameters for learning. I believe this is explanatory. Now, the way parameters are calculated is it's using the, let me use this out to explain it. Okay, let me see, sorry. Are you guys with me?
Yes, sir.
Yes, sir.
All right. So now, the first layer, linear layer, takes in what? 8 features, right? So now, these 8 features plus 1 from where? Where is this one coming from? Bias. You
Yes.
remember?
Mm.
Yes.
Yes. Which makes it what? 9, right?
Yes, sir.
Then 9 is multiplied by the output neuron it's giving us, which is what? 36, which is now what? 36 parameters, right? Then now for the
Yes, sir.
second layer, 4 plus what? 1 from bias, which is 5, times 2 gives
Mm.
you what? 10
Ten.
10.
parameters.
Mm.
Yes, gives you 10 parameters. Then now, for this particular model, the total learnable parameters we have is what? 36 plus 10, right?
Mm.
Which is
Yes.
what? 46.
46 is.
Yes. So that means there are 46 learnable parameters that this model have created under the hood to help achieve the end goal. So you can see how complex and how deep, you understand?
Mm.
You can see how complex and how deep learning implementation is.
Mm. Yes,
You
sir.
understand?
Actually.
Yes. So that's why if you're to use deep learning, you have to make sure that the task at hand has a lot of data, it has sufficient data so that it doesn't it doesn't overfit rather.
Mm.
Do I have any question? Okay, do you have any question for me?
Actually, I
Anybody?
got it. I understand today's lesson,
What
only that I
Hikma?
have to go and revise some few concepts.
Okay, yes. You have to revise yeah, learn more now. Hikma.
Same here, sir. Sir, my
All right.
question is, can you recommend maybe any machine learning books where these concepts might be
Okay,
learned, or
okay, books, right? Okay, yeah. There's a book I can't remember. It's a popular author in machine learning field, data science and machine learning. I think that's really, is it really, really good learning. I know really have good books on supervisory and supervised. Yeah.
please,
Um,
sir, can you type out his name? Yes, sir.
Really, just check out if O'Reilly has something on deep learning. It should be good. It's trying. Oh, yeah, really, I think really spelled Roiely.
Okay.
So, so you can just check out some of the deep learning books. Redmi is a great author. All right. Any other question?
No, sir.
Manuel, right.
uh, all right, Paul.
How's
Thank you. Good
Manuel?
evening. Am I audible? Can you hear me?
Yes, I can hear you. Too.
Oh, that's great. That's great. I actually don't have any question. I mean, I have a couple of questions, but there are things I have to work on by myself. But this is just for Hikma. I like to know correctly. Hikma, sorry. I believe I have some books that she might find useful. So if she is interested, I have them already downloaded in soft copy. She can reach out to me on deep learning.
I, okay, you see, you have books, right? Although I can barely hear you.
Oh, is it better now?
Yes, it is. Yes, it
Yes.
is.
Okay, I said for Hikma, I have some books. I'll have to dig to find them, but I have some books on deep learning that we find really useful, about two or three books. So if you're interested in Hikma, you can reach out to me.
All
I don't
right.
know.
Thank
Mm.
you.
Okay, how does Hikma reach out to you?
Okay, maybe I'll put my email or phone or WhatsApp phone number in the chat.
Uh,
All right, that's great.
All right, thank you.
Well done, Emmanuel. But
Thank
you're
you.
late to the meet. Why?
I'm very, very sorry. I went to do something. I thought I'd make it back in time, but by the time I was back, in fact, I was even
Mm.
discouraged to join. But I was like, at least something better than nothing. So yeah, I was occupied and I didn't make it in time.
Yes.
I'm sorry.
All right, there's no problem. Have you been through deep learning before? Come across it, work on something with deep learning?
Deep learning, yes, yes. Although my knowledge is very, very shaky because it's been a while. I actually even did much learning. But the last product I built was one that distinguished clothing types based on gender and
Mm.
trousers and glasses. So and
Okay.
I used Keras TensorFlow, but it's been
Okay.
a while.
Mm. Mm. Okay. 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 That's good. So you haven't implemented using PyTorch before.
I haven't what, sorry.
Have you implemented using PyTorch before?
No, not PyTorch. I've not used PyTorch before. I heard
Okay.
that PyTorch TensorFlow is better for production, but PyTorch is better for like I don't know the learning process. I don't know,
Development.
but
Yes,
uh,
yes. I have heard that I've heard of those arguments before.
I'm going to pick it
I've
up
heard of those
definitely
arguments.
before the end of this year. I mean
It
everything's on
was
data camp, so I'm going to pick it up PyTorch as well as TensorFlow. I have to know both. So yeah,
okay.
in your opinion, which one
Okay,
do you think
please
is
do.
better, or for me, for our level?
Your level,
Yes, which one do you think is better for of the two of them to constantly use to build models,
any of
PyTorch or
them,
TensorFlow?
anyone you can get your hand on, but go with I'll say go with the one that has when it comes to tool implementation, I always prefer the one with active of communities. Do you understand? Like where
Yes.
there's ongoing maintenance and updates, because those are the libraries that stand the test of time. Just imagine, okay, it's true. The argument that TensorFlow is better in production than PyTorch. For instance, that's 100% true. If PyTorch has an active community than TensorFlow, so no, they can say, okay, since this is the S TensorFlow has over us, let's create a more active use case for production environments. You can see Tensor and PyTorch have overtaken TensorFlow, isn't it?
Yeah. Yes.
Yes, yes, yes. And secondly, whatever solves your problem at hand, you might be okay at the end of the day. The features you need for your implementation or your end goal is found in TensorFlow and not PyTorch. So, of course, you have to use TensorFlow to understand. So you have to read the room, put all this into consideration before you use. Don't just stick, don't just stick with libraries anyway for the sake of this is the library I feel like using. You understand? It has to be what
Yeah.
helps you, what fits your goal, right?
Yes.
Yeah. So that's
Yes.
just my advice.
All right. All right. Thank you so much. Thank you so much, Paul. I'll take your advice to heart.
Yeah. All right. Okay. So we've actually closed the class for today. So I encourage us to just on your own because I believe the self development more. So do as much projects you can on every machine learning concept. Understand behind the scenes of how the algorithm works. and do as much projects as you can. This helps you grow even faster and more. And even projects outside the data camp, it doesn't have to be data camp. If you feel the projects in data camp is not sufficient, just look elsewhere. There are data sets on Kaggle. You can go on Kaggle and do data sets, um, uh, simulate a project idea and work on it. You get,
Yes, sir.
yeah, please build your portfolio, and when opportunity strikes, you're ready. You get, and whatever is left to learn, you learn them on the job. You get, and another thing I'll advise us right now is one of the mistakes I made during my learning course. I'm still learning anyway, don't get me wrong. But during my initial stage, I wasn't active with publicizing what I learned, because somehow, some way, these are ways people have been getting opportunities from. I think I said it the last time I took the class. We had a handful of people in the meet, but we are few, but I'll still say it. Whatever you learn, no matter how simple, no matter how uh little it is, just places like LinkedIn, you have an account here. You create an account. If you don't, you post. Say, hey, today I learned this and this on deep learning. You learn something new on deep learning, maybe one concept, or maybe how to reduce loss via activation function. You can say, oh, this is what I learned. Activation function, it helped me reduce loss function to this, blah, blah, blah. And you convert it to a business oriented view, like customer oriented view. Apart from sounding too technical, you also push it towards a way you can help uh, a customer or a user in some way. You understand? To reach an end goal. I mean, once you keep on showing up like that, like I say, there are people I know who are gotten opportunities through this. That's if you're work minded in space. Because I know some people have different reasons for learning skills like this. Maybe they learn for fun, or they learn to get a job and make ends meet. So this is just my few cents.
Yes, Philip, thank you. So, can I ask you a question based on what you just said?
Yes, I'm with you.
Um, about publicizing, you talked about LinkedIn, and yeah, do you think is there any other um option? I mean, including LinkedIn, is it only LinkedIn that's the best, or maybe is X also? I know that some developers, front-end developers, even UI UX designers, they use X, but then those ones, their work is more design oriented and it's quite flashy. But if you go to X now and you're talking about your neural networks and the number of layers and how you're able to optimize, they will not really get like the point of what you're saying. It's like it sounds like too much nerdy talk. So is there any other option aside from LinkedIn that we can use as well so that we can have more platforms where our works are visible to the where our work is visible to the public?
Okay, I think I don't know, maybe you're asking two things in one. One, I can figure out one of the questions you're trying to get is um how do you showcase your work, unlike front end engineers or UI UX who have visuals to display, right? Okay.
Yes,
Then the
yes,
second
yes,
question is alternatives for LinkedIn.
yes,
All right. Anyway, you answered the question for two. Apart from LinkedIn, you can leverage on X. But the reason why LinkedIn tend to have an edge is LinkedIn was built for this purpose actually, is to connect professionals to professionals. You understand?
yes. I understand.
Yes. So that makes LinkedIn uh more specialized for this use case and more easy. You understand? But X
Yes,
anyway cannot be written up. X is more like you have a lot of other purposes on X, depending on how much you fine tune your permission to use that word, fine tune your feeds to look like your timeline. Is it more of machine learning related concepts you get, or machine learning people, or people who can tend to give you opportunities, which is another concept. Let me talk about it before I answer your question one. On this question two now, publicizing, there's something you shouldn't care wrong. This is something I learned in this. Whether be it on LinkedIn, be it X, whatever you say you want to use, there's no problem. But the preference I advise us to choose is LinkedIn. Now, when you're trying to build your account on these platforms, I advise that you connect to people who could potentially be an employer or your client or a referrer in the future. Does that make sense?
Yes, it does.
Okay.
Yes. Example of these people are decision makers in the company, HRs for a technical company, maybe there are technical companies you research about, or you find this account and when you click on it, you see an HR for one of the companies that offer services you would love to work for in the future. You can connect. You see CEOs, founders, um, CFOs, all those decision makers, even CTOs, chief technical officers, build connection with them, connect. Then you show your activeness on the platform. You don't have to post every day, actually. Don't get it twisted. You don't have to post every day. There are people who just post once a week. But what matters is you can be able to you engage with the post or activities with these decision makers. You share ideas, you contribute to their posts. You understand? You get noticed, and maybe you could just code DM. Just code DM to ask for a job or to say, hey, you can do this, you can do that. Unless maybe they post the job and they say, okay, this is what we need. That's where you can actually do that. But if they didn't do that, you can just build a relationship first. Don't be in a rush. Tell them, hey, I love your opinion on so and so thing you posted on. And maybe it's a problem they need solved. You can say, did you try so and so? You understand?
Yes, I
That's it.
understand.
Yes. So you get to build the connection, and over time, there are certain times you read the room, you see how things are going. You know when you can now say, hey, this is what I do, just in case there's an opportunity. Plan. In that way, trust has been earned. You understand? If there's an opportunity, they will tend to look your way. This is something I learned recently and I've seen worked for other people. You get?
Yes,
Yes, sir.
boss. Yes, boss. Thank you so much.
Yes. Then
Thank you.
another thing for question one. Yes, question one. Now, um, your GitHub at this stage, your GitHub is actually your what's it called? Your show of proof. You understand? That's a
Yes.
show of proof. Your GitHub at this stage. Then, if you want to take it a notch, you want to take it up a notch, what you should do is you also include visualization um ends for your projects, such as you can use something as simple as Streamlit. Streamlit is very basic to implement. Streamlit helps you have a visual interface for your project. So maybe you create a predictive model to predict, like you mentioned, Emmanuel, to predict close right?
Yes.
Yes, you can have a front end part of it implemented without stress using Streamlit. You understand? You can just take guidance from any AI model, for instance, ChatGPT, to give you some line of code for Streamlit to implement a Streamlit interface, and there you have it. And if you have that, what's it called, the extra cost to host, you go on to host. They're free. They're even free hosting platform. I think there's Vercel. There's what's it called? A lot of them.
Render.
Yeah, there's Render. Exactly. So you just post on them, and there you have it. You have a project that is visually usable. You understand? But it doesn't write up that GitHub. In fact, I think there's this one of my friends I know. He doesn't have any visual project. What he has is GitHub because what I believe is the market understands the difference engineers. They know that front end will always have this visual to display. Back end will need to be tested. How will they be tested? We'll go through their GitHub, see how they implemented this, invite them on a call or an interview, ask them, how did you do this? What are your chain of thoughts? Give them a take-home assignment, you understand? Or yeah, do this, let's see how good you are. You get,
Yes, I get.
yeah. So there are different approaches to how they select these different engineers. So don't worry, once you, as long as you have the GitHub, you understand, where you post the project, then later you can now go through your GitHub. Maybe you've done, feel like you've done enough on more projects. You've done more projects. You can now go, okay, go back to this one, but say, oh, this project, I think I can visualize this using Streamlit. You go add Streamlit to the cake, and there you have it. You have something more pleasing, but not, it's not the only way to go about it actually. Does that answer your question, Emmanuel?
Yes, very, 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 very well. You gave me very what's the adjective? The comprehensive response. So yeah, thank you so
All
much.
right. All right, no problem. Any other question? Let me quickly get
Sir,
yeah, I'm with you, Salim.
for data analysis, can we use GitHub to showcase our projects, or we can use something different because it deals with visuals like Power BI visuals and something like that, like Tableau? Or can you suggest something
Okay,
different?
okay. So I advise you to use both. Excuse me. I advise you to use both. Why? GitHub gives us this idea that you have the ability to collaborate on a team because that's the essence of GitHub. Yes, that's one very good use of GitHub. Okay, you create a tool. Let's say your chain of work is after analyzing data, even at the level of machine learning, or for let's say after implementing a model, you have to pass it to an AI engineer, depending on how distinct your roles are in the company. How do you pass that model to the next person to work with or to do something with it? It's not you can't send their ability. You understand? The way you can
Yeah.
do this, one of the ways you can do this is to you push whatever you work on, and from there, the person who wants to work in this will pull, GitHub pull. I believe you should be conversant with this GitHub command. To do a GitHub, have see whatever you worked on and add whatever they want to do or whatever they wish to do with it, you understand? So you see that is team collaboration. You understand?
Yes, sir.
Yeah, so that's why GitHub is used. GitHub is not the only versioning concept or technology we have. There is GitLab, there's GitLens or something, Gitbucket. I'm trying to remember the name, but GitHub is just yeah. So advice if you can be able to use GitHub, please push to GitHub. In fact, learn it. It's very important. That's where you can convince someone that CI/CD. That's the summary. CI/CD. Then for visuals, yes, of course, you have to visualize. Very important. Tableau, Power BI, yes. Uh, implement. You understand?
Yes, sir.
All right. Let me quickly drop the link. Meanwhile, if there's any question, just ask. I'm trying to get the link. Sorry, so that we just end the class for today. Right. You know. All right. I've dropped the attendance link in the chat. I guess no question.
Yeah, no questions. No questions.
Okay. So let me quickly say something before we close today. In addition to what I mentioned about social media presence, size, Uh, let me still talk about the first point that I discussed. Please, your field. Don't be careful of who you connect with. If you're trying to leverage social media for yes to build in public, that's how they call it. You should be mindful of who you connect with. You understand? Unfortunately, there's not there you shouldn't connect with everybody that comes across your feed. Yes, you have to be intentional of that. You ask yourself, is this person capable in the future to offer me an opportunity? These are the questions you ask yourself before you do so. So that means you can't just see someone who does something entirely different and the connection is not there in the future that this will lead to something great for me. You know, because the algorithm, the social media algorithm learns from what you engage with. So if you see that you're connecting with people in this field or concept, it keep on passing that to your timeline with it. And if it's not something you wish to, or it's not something compatible with your purpose in the future, it becomes a problem for you. And another thing is the currency you want to earn with. Yeah, you want to earn with, yes, in the future should be the region you tend to engage with. Okay, let's say you love the Chinese currency, the yen. You connect with Chinese people. Okay, knowing that okay, in the future I'll be getting a Chinese client and I want to earn in yen. You get if it's the US, you know you should be expecting the dollar. If it's Canada, you're expecting what the Canadian dollar. I believe this makes sense.
Yes.
Yes, sir.
All
Yes,
right.
it does.
Okay. Then and finally another thing is okay, another thing is um try as much as because with the I'm not trying to scare you guys, okay, please. Don't get me wrong. I'm not trying to scare you. Just know that I wish the best for you. So that's why I'm telling you this. Given the current situation of the market, the job market, there are jobs. Yes. The confident part is there are jobs. But these jobs are for people who are kind of experienced. I'm not saying entirely experienced, kind of experience, yes. But there's a loophole to this. And what's the loophole? Two ways that I can think of now. One, learn as much as you can. And when I say learn as much deeper as you can. Don't just okay, say, okay, I'll just make a model that just does something video and that's the end of the day and I'll relax. No. You start from small. That is good. But when you start from small, seek to move to the intermediate level. So that means doing intermediate projects. And when you've done some intermediate projects, you can take it up a notch. Go to projects that are more that showcase more mastery. You understand? So be don't just do mediocre uh projects and say I'm ready for a job. Because remember, you're in a fast taking and fast moving industry tech. Everything's are changing by the day. Research papers are pulled out, you understand? And concepts are getting more advanced, you get. So you have to be upgraded with this concept, you understand? So that you stand a chance in the market. So that even if they say, okay, we are looking for entry levels, you see that you have more edge over your other the mates you have for the same job post or opening. Then the second way to beat this jobs for expertise concept, given the current trend, is sometimes volunteer. In fact, yes, volunteer. Just once you know the okay, you gotten to a level that okay, you can start contributing to projects. There are two ways. You can volunteer or you open source. You contribute to open source. Do we know what open source is? What open source is?
Yes, I do. I don't know if you
Okay,
that
no, no,
question.
no.
I don't want to help
Let
everybody.
me put it together. So open source projects are projects that are, let me summarize. These are projects that are public and accommodate support from other people to help this particular say project to grow. Maybe fix bugs, add more features, you understand? Whatever support and help the project grow, that's an open source project that gives that freedom. There are certain projects that are private, you understand? But in this case, open source projects are public. So this is where you leverage, this is the opportunity you have to leverage on. Look for open source projects in machine learning and machine learning engineering or AI, and you contribute. Contributing now, you see that you get to have this real experience. You see how real life operation looks like. You see how team collaboration moves. You see how um, you learn certain production concepts. You write production uh, models, I should put it that way. You understand? Or you volunteer. You can just look for maybe startups. That startups are more in there to get this volunteer roles with. You just see a startup, okay. You write an email to one of the decision makers, maybe the founder, because at startup level, most of these decision makers are very accessible. Yes, very, very accessible. In fact, you can even get as much as the what's it called, the founder of this project. So you can tell them, hey, this is what I'm a machine learning engineer. I've been able to build this. I have this idea. I see the project. You have to be intentional. You have to be searching this startup. Okay, this is what they're doing. I think you're doing this. I would love to contribute to the project and listen to see success, blah, 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 blah. Most of the time, I mean, who doesn't love free work? To love you, to be happy to have you on their team, to contribute. You understand? So with this way now, you're building experience. Yes, you don't wait until okay, wait for a job. A job might come, but when and how ready will you be when the job comes? That's another question. So these are cases where you close that gap of lack of experience. So that's just what I wanted to chip in again for us.
Thank you very much, sir.
Thank you very much, sir.
All right, all right. Are we building the what's it called? The attendance for today?
No, sir, the link is not opening.
It's not opening.
Yes,
Yes.
we cannot copy it. It's like you pasted a link text, not a link address.
But can you open? Emmanuel, how about you? I can open it from my end. Emmanuel, could you please?
I said I'm able to. Can you hear me now?
Yes, I can hear you.
I was able to open it. I don't know. I'll
Um,
put it
uh,
again. If well, I think it's the Google Meet style of doing things. What you can do is to screenshot the link, then open it in Google Lens. Then you can use Google Lens to copy the text from the picture.
okay. Hikma and
That's what
Salim,
I did.
can you do that?
Yes,
Anyway, I've
I
tried
did
to
that
post
for
again.
mine, but it's still not opening actually. That's what I did.
I've, I've dropped the link again. Is it clickable now? Check if it's clickable.
It's still not clickable.
Oh wow.
It appears like a text, not a link. So when we click it, it will not open.
That's absurd. Mm, okay, you know what? I don't want to drop this in general platform where others who are not in attendance will feel. So have you guys been able to message Emmanuel? So Emmanuel, what you do is just send the link to them on their DMs. You understand? Or oh wait, let me do that directly. That's my WhatsApp number there. Just DM me right now so that I'll drop the link for you to feel WhatsApp. Okay? Hikma and Salim.
All right, sir.
All right, no problem. So that will be all for today. Thank you guys for joining, and see you next week.
Thank you
Thank
very
you,
much,
sir.
sir.
Much.
Right,
See you
bye.
next week.
Yeah, see you soon.